Okay, thank you very much for coming and spending your time to come and listen to me prattle on for about 40 minutes or so. My name's Mike Sweet. I'm a lecturer at a university in the UK called Derby. It's right in the centre of the UK. It's a very strange place for a coral biologist to be. But I'm going to tell you a little bit about the work I've been doing over a few years and introduce you to how microbes can control coral reefs and the effect they have. So just to set the scene a little bit, obviously I would hope most of you guys know this, that coral reefs are very important ecosystems and they're often referred to as rainforests of the sea due to their diversity. They represent some of the densest and most varied ecosystems on Earth. And although the world's reef only cover about 0.2% of the total ocean's floor, they can harbour nearly 1 million species found in and around them. And we haven't even touched the surface as far as species identification goes. So if anybody's a budding taxonomist, that's an area of research which is currently limiting in staff and researchers. Not only are they important for biodiversity, but they act as efficient coastal defences, nurseries for reef fish, and they're very important for tourists, as you well know, being in the Maldives. Currently, over 500 million people are thought to depend on reefs, and it's always very difficult to put an economic value on an ecosystem, and that's why there's a big range here, but it's thought to be about 70,000 to 500,000 pounds per square kilometre per year, and that's for things like as a food source, for tourism, and for its coastal defences, just to name a few. Corals come in all shapes and sizes, and this is just a whistle-stop tour of a few different things. These are soft corals, also known as anemones and things. Then you get a lot of the octocorals, known for their 8 tentacles. These are the hard scalactinian corals, which are your reef-building corals, and probably the most famous of the phylum Cnidaria. And this is what most tourists like to come and see, and particularly this is what I work on as far as research is concerned. Again, these come in a variety of different shapes, from tabular acroporids to massive parietes. These parietes are the slower growing species, whilst the acroporids are sometimes referred to as the weeds of the sea. They can grow quite quickly. On average, they grow about the size of a finger in a year, but it has been reported that they can grow up as 10 to 20 centimetres if conditions are very good, whilst these parietes grow a lot slower and therefore live a lot longer. This coral is sometimes referred to as a cabbage coral, just due to the foliation around it, but again showing the diversity just within this group. But although coral reefs have been around for a long time, they're threatened worldwide. It's a phenomenon which is occurring all over the place. And currently 30% of the world's coral reefs are categorized as seriously damaged. 60% of the world's reefs are thought to be at risk. So that's showing that they're getting close to categorized as seriously damaged. And that's already 90% of reefs in general are struggling. By the 2030s, it's estimated that 90% of all reefs are going to have some form of threat, and this is largely down to human activities, human involvement. So they're under a lot of pressure and a lot of stress. They're under natural stress from things like cyclones, hurricanes, El Nino, which is thought to come, we're in the El Nino year now, so the reefs again are under threat from this natural phenomenon. Tourists, they quite like to stand on them, use them as a breathing platform. Although not touching corals itself is going to be a major stress, if you replicate that up by the number of tourists you have in the sea, it can become quite a significant threat. Obviously, we've got a lot of rubbish in particular areas. It's very difficult to get rid of this properly, but a lot of things like the plastics, and particularly things like the burlap sacks, cause a lot of damage. They stick to the corals and they can kill corals quite quickly. Overfishing, it's a big problem to do with if you're removing certain key components of an ecosystem. And as the reefs are obviously very important for a lot of fish species, if you remove certain key species there, like the herbivores, the big parrotfish and stuff, you cause phase shifts, which we'll have a look at slightly later on. Things like ship groundings and pollution coming from the ships as well, particularly things like oil, causes major problems, and they actually cause just major gashes through. This happens a lot in places like Egypt and around the Red Sea. Quite often ship groundings cause multi-million pounds worth of damage, and there's a lot of business focused around this sort of thing to do with consultancies from both sides. You have the consultants who are hired as far as the country is concerned to try and give it this economic value associated with the damage caused, and then you have consultants hired from the ship companies as well to try and bring that price down a little bit, because both sides usually inflate the cost of damage which is also caused. So if anybody's interested in that sort of aspect, come and have a chat with me later and we can talk about potential job opportunities associated with reef biology. Coral collection. Collection is quite common, particularly in places like Fiji and Indonesia, is where most of Europe and America get a lot of their corals from. It's starting to become a lot more managed, however it still causes a slight pressure and another threat facing corals around the world. Nutrification coming in, land runoff causes mass problems as well. Increases things like algal blooms, and one of the problems with crown of thorn starfish is thought to be associated with land runoff, the nutrients coming from these areas. Quite common in areas like this again, you've got anchor damage, similar to the ship grounding, causes a physical destruction of the reef itself. This little chap is the crown of thorn starfish. A natural predator of corals. It's perfectly fine at low numbers, but what we've started seeing, and in some places it's been reported in the Maldives particularly, where you get increases in the number, mass groups of them congregating around particular reefs, and they can destroy an entire reef system very, very quickly. They're very difficult to get rid of, as with most echinoderms, particularly the starfish and the sea stars. If you chop them in half, they carry on growing and you're just making more of a mess. And they have a lot of gonads, so when you chop them, they often release sperm and egg into the water column, and the problem doesn't go away. So the most common one is handling, just grabbing them up, taking them onto land, and having to burn them, unfortunately. But like I said, they do actually play an important role in the ecosystem. On low levels, they actually cause an intermediate disturbance to the reef and allow for a greater diversity of corals to grow up. This represents global warming or climate change. I don't need to go too much into detail. I'm sure you guys all know the ins and outs of this. But temperatures, or global sea surface temperatures, are generally on the increase, and we'll have a look at some facts and figures in the next few slides. But it's causing major stresses for the reefs in general. With that comes coral bleaching, and this is the loss of the symbiotic algae, the zooxanthellae, associated with all these skeletinian corals, and it puts them into a stressed state. And then when the coral's stressed, it makes them more susceptible to things like coral diseases. This is what I principally study, and this is what we're going to have a look at for the rest of the talk. So with all these additional stresses, the corals are struggling and moving from this original ecosystem, this very diverse community, hosting a whole wide range of different life, and it's moving it in something called a phase shift to a more algal-dominated area. And this is classed as a degraded ecosystem. It's actually not as bad as this picture portrays it. You're moving from one system, one ecosystem, to another ecosystem. So in places, if you ever get lucky enough to go and dive in the Caribbean, you can actually see how the reef systems are changing. The Caribbean got hit quite badly as far as coral disease is concerned, and particularly from the loss of a major urchin called diadema, which was a major herbivore, similar to what the parrotfish sort of play here. And they saw this big phase shift moving on to algal-dominated reefs instead of the scalactinian-dominated reefs. But you get a completely different ecosystem. So there was a recent study which shows that actually fish diversity increased once it was an algal reef system instead of the coral reef. But you're getting completely different species. So you've got to think about the importance of different systems as well. Just because it's not a coral reef doesn't mean that the ecosystem around the islands in this instance are any less important.